Okay, so it's 2 o'clock. I still see some attendees trickling in, but I'd like us to get started. Good afternoon, everyone. My name is Nicole Van Wert Quincy, and I appreciate you joining us today. I'll be your moderator this afternoon. Our webinar topic is automating and documenting temperature calibration. The topic is being presented by Ron Ainsworth from Fluke Calibration. He is the business manager for process calibration tools at Fluke Calibration. After graduating with a degree in physics in 1998, he started in the primary temperature calibration laboratory in American Fork, Utah. He has since had roles as a laboratory manager and marketing manager at Fluke. We expect today's presentation to last roughly 30 minutes, and then we'll answer any questions that have been submitted during the presentation. And as a reminder, during any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention that this webinar is being recorded. Each of you will receive a follow-up email in a few days with the link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Ron.
Hi, and thanks for being here. I'm happy to be sharing this presentation with you on automating temperature calibration and documenting it. And I think there's some useful ideas here that you may want to consider implementing in your own calibration processes. You know, with automation, there's a few different reasons why you might want to do this. Trying to my presentation didn't advance. Here we go. There we go. One of the reasons that you'd want to consider automating temperature calibration would be to be more productive. So, you know, you've got a number of repetitive tasks that can be time-consuming and pull you away from other things that you could be doing when you're doing that calibration manually. And when you automate, of course, you can avoid doing those repetitive tasks and be taking care of other business. Or maybe go make yourself a cup of coffee. But at any rate, you can be more productive with automation. The other side, though, is that aside from being able to step away and do something else, you can also be confident that your results are consistent. It'll be done the same way every time because you've programmed it to do it the same way every time. And then that way you are confident that your results are consistent no matter who does the work, and your results are going to be more meaningful in terms of determining things like drift or out of tolerance conditions, etc. So what we're going to look at is 3 practical solutions to doing automation of a temperature calibration. So one method is that you may or may not know that a Fluke dry block or microbath can be automated by a documenting process calibrator. And this may be, it's not just something possible with Fluke instruments, but it is one of the leading methods of doing this. The 754 connected to a dry block. So we will talk about how and why you might want to approach that type of calibration. The next one would be automating without software. The documenting process calibrator, by the way, you would need to use DPC track to collect the data. So that's differentiating it from the next one. Automating without software, the 1586A can be connected to a dry block to automate it and collect the data also. We'll talk about how that works and pros and cons. And then the third is using software for performing the automation. So we'll run through an example of that and again talk about pros and cons of using software for automating the calibration. So the first option that we're going to talk about is using the 754. So 754 can be connected to any of the Fluke dry blocks or the microbaths. You can configure the test by if you've used a 754 before, you know that you can choose whether you're going to be sourcing pressure or temperature, that sort of thing. When you source the temperature, you can choose to source an RTD or a thermocouple where it more or less simulates those values. But there's a third option. You can choose to source with a dry block. And so that's what we're going to talk about is how you would source with a dry block or microbath for that matter. And then you can measure whether it's a thermocouple output or a 4 to 20 milliamp transmitter. We're going to go through an example of doing it with a transmitter. You can set up a simple routine that'll go through various temperature points, and we'll discuss how that works. So in the final results, they may all be stored in the 754, but when you want to pull them out and use them for reporting and documenting and all that, DPC track software is what you would use to collect all the and organize all of the data. So first off, let's answer the question of why is a dry well even required? Many of you may already be using the 754 to perform temperature calibration, never used a dry well before, and wonder what is the reason we'd even need a dry block. So when you're simulating a thermocouple or RTD or sourcing the voltage or resistance from the 754, one of the things that you're doing is neglecting the temperature sensor. You've actually disconnected it from the circuit. You're just focusing on whether or not the transmitter is reading correctly. Sort of assumes that the temperature sensor must be perfect. But all sensors drift over time, and when you ignore the temperature sensor, you're actually ignoring the largest source of error. Rosemount estimates it to be about 75% of the error in a temperature measurement involving a temperature sensor and a transmitter. So what you see on the left is just an illustration of a process with a temperature sensor inside of a vessel, and then it's connected to a transmitter, a little green item there, and then that's being read by some in a control room on a panel somewhere. And so you can kind of see if I got to disconnect that sensor and hook up my 754 to it, like you see over on the right, I'm not even testing the sensor. It could be drifting, it could be experiencing all kinds of issues, and I wouldn't even know it. So that's why we want to include the dry block. The dry block is going to help us include the temperature sensor in the calibration. So what does that entail? Well, first thing that we need to do is remove the temperature sensor from the process and put it into the dry block. It remains connected to the transmitter, and we connect the transmitter, the 4 to 20 milliamp output, to the 754. And what we're going to be doing is changing the set point temperature on the dry block via the 754. We'll have the temperature set points pre-programmed and a delay. So let's say we set it to every 20 minutes, it's going to change the temperature to a new temperature, wait 20 minutes, and then take a reading. So I might go through 0 degrees Celsius and 75 and 150, etc. And then the current output, you can kind of see in the second column on that blue table up there, would be some milliamp output that would be read by the 754. It would keep track of the temperature reading from the dry block and the output from the 754. So that's the concept here. How does the dry block know what the temperature is? If you look down in the bottom of that red circle, there is a control sensor down there. It's a little RTD that's in the block that measures the temperature right at the bottom of the dry well. And the display on the dry block is what's also recorded by the 754 through the communication. How does it communicate? Well, it looks like this. We do need to connect the 754 to the transmitter. I just got a little illustration of the connections there on the left. But then on the right here, we need to hook up a special cable to connect to the dry well. So there's it's called the Hart dry well cable. That's the model number, and then for your convenience, I've got the part number, the Fluke item number, also listed right there as 2111088. What it consists of is it's an RS-232 cable with a LEMO connector on one side, and then it's got a special null modem connector on the other side to make sure that all the connections line up correctly when you connect it to the serial port on the dry block. The kit also has the ability to allow you to hook up to the smaller handheld dry wells as well. As you can kind of see, it's got the stereo jack connection that goes with the smaller dry block calibrators. The last step is you're going to hit, well, not the last step, but the last one on the slide is you're going to hit the heart button, the little yellow button that I've got circled in red, and then it's going to check the transmitter for its configuration. In the setup, I gotta go and enable the loop power on the 754, and then I need to tell it that I'm going to measure milliamps and source dry well, as we talked about before. You press the heart button to get that done, and then I'm going to select as found to configure it for documenting the as found part of the test. And when I get into the as found, there'll be a number of options for me to go ahead and select the time interval I want the temperature to change at, and what the number of temperatures that I want to do, and whether I want to go up or down or up and down, those kinds of things. So the kinds of options I have, as I mentioned before, there's a wide variety of temperature sources that can be used with the 754. All of the Fluke dry block calibrators you can automate with the 754, and the kinds of measure options that you've got, as I mentioned before, you got the 420 milliamp loop power. You can measure the output of an RTD, say in ohms. You can measure thermocouples, RTDs, that sort of a thing. Now the key thing to remember is that if you're looking to get a 754, remember that you do need to have the DPC track software as well in order to be able to complete the documentation part. You want to download the results to your computer and keep track of your assets and that sort of thing. That's what the DPC track software would be for. Print a variety of standard reports with it. Now, so that we went through this kind of quickly, but gave you sort of the main ideas. But we've got some application notes out there to help you to be able to do this on your own. We've got an application note on the left called Eliminating Sensor Errors and Loop Calibrations that kind of walks you through the screens of setting up the 754 with a dry block, and then you'll recognize some of the illustrations over here on the right in the presentation. There is a brochure, catalog, application note kind of a document that we've got called Temperature Applications and Solutions that I believe you can actually download from the Transcat website, that covers a number of different applications, including this one, walking you through the steps of doing it. Now, the next solution that we want to talk about is automating with the 1586A SuperDAC. Now, you may not be that familiar with this particular product. It is a pretty versatile tool. It's a readout. You use it for measuring thermocouples and RTDs, and it's great for calibrating in a large volume if you need to. So that little DAC stack is the instrument on top of the 1586A in this picture, and I can connect up to 20 different probes to the top of that instrument and calibrate them. That's kind of cool. Can get a lot done whether I'm doing calibrations in baths or I'm doing a profile of an environmental chamber. Lots of things you can do with it. But aside from its functionality and being able to read a lot of data and do it very quickly, up to 10 measurements per second, I can automate the dry block. I can connect it with an RS-232 and set the temperatures and collect the data and come back and just collect it with a USB port. And no need for software here. Although, if software is helpful, there is a light data collection software program called Fluke DAC 6.0 that does come with the instrument. But we're going to talk about doing it without the software. So first off, just so you can see what there's two ways of using this. One is with this high capacity module where I can have a fixed set of probes that are connected to it all the time. That may, that might be great for profiling chambers, that sort of a thing. And then this other, with a quick connect DWF connectors on the top, where I just press the button down to easily connect my thermocouple or my RTD. Either one of those can be used for making the connections to the probes, and I can collect up to 20 megabytes of data, so about as much as you need. And PRT is quite accurate, up to plus or minus 0.005 degrees Celsius. Thermistors at 0.002. It's a very very useful tool. And it can control all of the Fluke temperature sources. So the 9118A thermocouple furnace down at the bottom, or it can control the Fluke baths or a dry well, you name it, it can control it. So that's it's a pretty powerful tool in that regard. So how do I set this up? Well, first thing I need to do is connect the dry well to the 1586A through the serial connection, and you just use the regular RS-232 cable that comes with the unit. So that's one difference between this method and the previous method, is I did need a special cable in order to pull off the automation with the 754. This one, it comes out of the box. I insert the probes, I connect them to the 1586A, and then I just start pressing the buttons on the front panel. The first is channel setup, and there I select all the probes that I want to measure. And then I press test setup, and there I'm going to determine what set points. That's the screen on the upper right here. Kind of shows what that looks like. I can add as many set points just about as I want. I also will determine what's the tolerance that I'm going to accept on that set point. For example, I could hold it to within a degree, or a tenth of a degree, or even a hundredth of a degree. It won't take the data until it gets to inside of the tolerance. It also won't take the data until it meets the stability criteria that I'll set on this screen, and it will also wait until I've completed the soak time if I also wanted to make sure it waited a certain period of time. So those are unique features about automating with the 1586. I start the test, and then the results are stored on the 1586A internal memory, and I can collect it with the USB. There's an application note that we have written on all of the details of going through and setting up the automation for this, and there's obviously details in the manual as well. But the app note I've got referenced in the bottom right here. So the last thing is what do these results look like? Well, they're stored on a CSV style format. They're easily read by Excel or any other analysis reporting tool that would read a comma delimited file. There's going to be two files that are stored with each test. One is a setup file that records all the configuration details. You can store a bunch of different configurations in the 1586A. You can also record what those configurations were in that report. And then the data, which you can kind of see in the bottom right, it'll have all of the data that was recorded, and you can use that for your data analysis. Go in, create your calibration coefficients, your tables using whatever method you prefer. The third method that I want to talk about is using METtemp2. So METtemp2 is a software method of automation. It works with all of the readouts and temperature sources in the Fluke lineup, except for the 1586A. So the instrument we just talked about that could automate everything on its own, it's actually not supported by METtemp2, which is I wish I could report something different, but full disclosure, those two don't work together. But the interesting thing about METtemp2 is that I can control many different temperature sources with it. So this, you can see that it's not just software, it comes with some hardware. At the bottom right there's a smart switch, and you might be able to see that there's some some RS-232 ports at the bottom. There's 6 RS-232 ports that you can connect up to 6 instruments with the smart switch, and then that'll be connected to your computer. And so one of the cool things about METTEMP2 is now if I've got to cover a wide temperature range, I can hook up baths at different temperatures or dry blocks at different temperatures, and when one portion of the test is finished, move my probes over to the next portion, and METTEMP2 will collect all the data, make sure that all the data for the probes stay together, and it will even help generate the report and the coefficients and the tables and all of that at the end. So it's a wonderful way to avoid sometimes a good deal of confusion can happen when you're writing down or collecting in different ways all of the different probe results, and this way it won't get mixed up. It'll get done without you having to stand there waiting for it to be done, and again, you can cover your entire temperature range because you can handle multiple probes. So you can watch it go in real time, see how the stability is looking, and watch the data as it's being collected if you want to. You can use this program for thermocouples, RTDs, SPRTs, but for doing SPRTs, you do need to be a little bit. It depends on how careful you want to be about the RTPW values. Some people, when they're doing ITS 90 calibrations, want to collect the triple point of water after every temperature point. This is going to use an average RTPW value. It'll do thermistors. You can do liquid and glass bimetallic. Pretty much your entire workload you can manage with METTEMP2, and it is a unit that again will support all of the different readouts, probes, and temperature sources that we offer at Fluke, except for the 1586A. The way this is what it looks like when you're setting up a program. Not exactly laid out like this, but these are all of the items that you take care of when you're setting up METTEMP2. You've got to take care of the communication side with getting the COM port, the RS-232, and setting up the smart switch. It's got to all be connected to the computer, and then the RS-232 cables need to be connected to the various instruments that you want to control. And then in the setup, you're going to choose your reference readout and your temperature sources, and you can even, as you can see on here, collect the data from the 1620A Duke temperature and humidity monitoring unit that we've got, and that way you don't have to be manually recording the temperature and humidity during the test. It's all being done automatically, and that's another great reason to do automation this way with software. This is what the actual program looks like, and it's pretty simple in that it walks you through each of the different steps. You go from step 1 to 2 to 3 to 4, and as it'll help you to choose the right instruments for your test, and then you start the test up. It is a pretty simple way to automate your temperature calibration, and I think aside from all the time savings that comes from doing the automation and we love being able to run our calibrations overnight when we can do it all in one bath or one dry block, and come back in the morning and collect the data. But aside from that, when you're with temperature, you've got a bit of work to do to take all the temperature and resistance pairs and turn them into calibration coefficients for the ITS 90 or Callendar Van Dusen, generate a table or a report, and that's where I think the software is particularly useful, because it will do all of that for you. And there's not very many people that that have got all the skills to be able to do that in, say, Excel or something like that. So the runtime in METtemp2 will keep track of the elapsed time. You can see how long the test has been running. You can see which set points you're on. It'll keep track of the tolerances. You'll be able to see if how close you are to the set point, what the stability is. It indicates which temperature source is being used at the moment. You can keep track of your reference readings and the output from the unit under test. So all of that will be displayed on the computer screen if you want to monitor it there. And then, as I mentioned before, you can generate all of your calibration coefficients for PRTs, thermocouples, thermistors. You can do it in ITS-90, Callendar Van Dusen, IPTS-68. For thermocouples, you can do, thermistors, you can do the Steinert-Hart. You can even do polynomial equations if that's what's needed for your particular readout or requirement. So it's a pretty capable piece of software for completing the automation. The reports look like this, and there's some customization that you can do to the reports, but it'll put in the model and serial number, your address, whatever you need on there. In addition to the results of your calibration, it'll indicate what the actual values were, what the unit under test read, and it'll indicate the residuals. So the difference between what the actual the difference between what the indicated value was and what the ideal curve said it should have been. And that's a nice way of determining how good the fit was for your calibration. If you take enough calibration points, those residuals will be a great quality check to tell you if something looks wrong with this curve, and maybe we had something get messed up. Maybe go back and check a point or two. In some cases, you might have to redo a calibration if you catch that you made a mistake. But without some analytical check like that, you may never even know that there was a problem with the calibration. So anyway, a useful thing, and it'll list all the test equipment, of course, along with the recal dates for your traceability. The tables, a very handy way of, your customer may appreciate it because they might not have a fancy readout. Maybe they're using a DMM, or they want to be able to double check something. The table can also be printed by the software. So we'll jump back to the questions in just a second. I'll do a quick summary then of what we talked about. With a deep 754, we're able to do calibrations of PRTs, thermocouples, and transmitters. Didn't mean to have thermistors there, but transmitters. With the 1586A, we can cover PRTs, thermocouples, and thermistors. You could read a 4 to 20 milliamp output from a transmitter, but you could not power the loop with the 1586A. With the METtemp2, I can do all the SPRTs, PRTs, thermocouples, thermistors, liquid and glass bimetallic thermometers, but I really don't do 4 to 20 milliamp outputs from the transmitters. So when you're doing stuff in the field, 754 and the 1586A, the 754 better for if you're doing it with transmitters. 1586A could be done in the field without having to have a laptop, but it's really just going to be reading the output of PRTs, thermocouples, and thermistors. And then when I'm talking about if it's really important for me to have documentation, I'd be more interested in the 754 if the thing that I really need to be able to do is I'm really working this in a laboratory and I need to produce calibration reports and coefficients and all that. I'm leaning towards METtemp2, and just for a powerful way to automate the collection of all of the data and collect it, it's hard to beat the 1586A. It's got some real capability there. And one of the things also, by the way, we didn't mention with the 1586A is I can watch it graph. I can watch the data graphed out on the display in real time, which can be pretty useful for seeing how stable things are and troubleshooting and all that. Okay, so uh, do we want to, Nicole, did you want to do questions now or come back to that?
Questions, but if you would just go to the next slide so I could talk to the...
You bet.
Yep. So I'm going to go to questions, and as a reminder, if you'd like to submit a question, you can send it through the question box in your webinar controls. It's on the right side. And I just wanted to highlight a promotion that's going on through the end of the year. It's a gift with purchase. Depending on your purchase value, you can receive a free Fluke or Fluke calibration tool with up to a $1,350 value. So if you'd like details on that, you can go to transcat.com/deals. If you go to the next page, my contact information is on there for everyone. Okay, so again, I'm with Transcat. My email is there, phone, and our website, of course. If you guys have any questions after the webinar, feel free to contact me. So I'm going to start with the Q&A right now. So first question, how long should the delay be set between measurements for the 754?
Okay, so that's a good question because one of the things that probably I would like to emphasize maybe just a little bit more is that with the 754 it just changes the set points on a timer, and so you do want to be careful about setting that delay. And the way you do it is you look at the specifications on, say, the dry block, and when it's going up in temperature, there'll be a spec for how long it takes to get to a temperature set point within a particular temperature range, and you'll want to take that value, like let's say it's 10 minutes to get to 300 C. You want to take 10 minutes and add to that some amount of time for it to stabilize. And there will often in the specs be a stabilization time as well. So maybe it's 10 minutes plus 2 minutes, and so you've got 12 minutes, and you would set the delay in that way. Now also when you set the delay on the 754, it's actually in seconds. So I take that 12 minutes and multiply by 60 to get to the number of seconds in the delay. And then what it will do is change that temperature to the new set point for every set point on that delay. So you want to base the delay on the maximum one in your run. So yeah, great question.
Okay, next one, is METtemp2 compatible with non-Fluke products?
All right, so METtemp2 is not compatible with non-Fluke products. It is compatible with all of them except for the 1586A, but it would not be compatible with non-Fluke products.
Okay, does DPC track come standard with 754?
DPC track is something that you would need to order separately. It does not come with the 754. So that would be a pretty important point. If just getting the 754 will not get you DPC track.
Okay. Why can't I use the serial cable to connect the 754 to a dry well?
Okay, so the 754 serial connection has got a couple of pins in it that are not lined up with the correct pins in the dry block. So there is a special connector that comes in the kit that it's called a null modem, that will switch those two pins around so that it does connect to the right part of the right place in the input for the RS-232 on the dry well. Yeah, so if you tried to make the connection without those, it just won't work. So it is necessary to purchase the kit. Again, it's a Hart dry well cable kit.
Okay. Okay, last question. Can I reference, or can I use a reference probe when automating calibration with the 754?
No, you can't. That's also an important a point with the 754 is that I can conduct one unit under test to the 754. I can't collect data from multiple units, and that also doesn't give me a place to connect a reference. So the only temperature that you're going to get for the reference temperature is the indicated value on the dry block. You would not be able to use, say, like a 5626 to get a more accurate temperature reading. You would only get the reading from the dry block.
Okay, another question came in. To follow up on the first question, how long would it take to perform a 3-point calibration with a 754, assuming a 12-minute stabilization time? Is it 36 minutes, or are there other things to consider?
Well, okay, so if you had a 12-minute stabilization time, we'll just break it up. So the 12 minutes was 10 minutes to get to temperature and then 2 minutes to stabilize, or maybe it's 5 minutes, but let's say it's 12 minutes. Then the time it would take to complete the calibration if it was 3 points would be 36 minutes. Because it will wait 12 minutes after setting the first set point. Then it will take that first measurement, and then it will change the set point, wait 12 minutes, and take the next measurement, and then it'll do it one more time.
Okay, and another attendee asked if there are any issues using a 753 rather than a 754.
No, there's no issue with using the 753. It will also work, as will the 744 and I think the 743 also, but that one so that's an older unit, but certainly the 744, the 754, and the 753 will all work.
Okay. All right, so that's it for questions. That concludes our time for today. If you have further questions or would like to find out more about Transcat's product and service offerings, please contact us at 800-800-5001 on the web at transcat.com, or you can email me directly at nvanwert@transcat.com. Thank you for joining us today, and we hope you got something out of the presentation and that you continue to join us for our future Transcat e-learning webinars. Thank you, Ron.
Thank you, guys.
All right, take care.